In this video, we'll show you how we perform Experiment 5 in the laboratory. The goal of this experiment is to determine concentrations of solutions via titration. It will be helpful to follow along with the experiment as you watch this video and answer questions as they pop up. In this first part of the video, we'll show you how to prepare a standard solution from the solid. First, you obtain a weighing vial and press tare on the balance so that it reads 0 grams. At this point, you can take the oxalic acid dihydrate solid and add it directly to the weighing vial. You should add between 1.3 and 1.5 grams of the solid. As you see here, I keep adding more until I've reached the desired amount. Make sure to cap lids on any container you use so that chemicals do not get extra water in them from sitting out. The mass I'm recording on the data sheet is 1.450 grams. I will also make sure to sweep off any acid that landed on the balance so as not to corrode it. This is good technique because we want to make sure to keep the balances in good shape for future students. There are brushes provided at every weighing station for this purpose. Now I'm going to take my solid to prepare my solution. At the lab bench, I have a 100 milliliter volumetric flask and a funnel. I add the solid directly to the funnel and wash it down using the distilled water. Notice that any solid that remained in the funnel just gets washed down as I continue to add water. I will also rinse out the weighing vial. The purpose of using a weighing vial instead of paper or a weigh boat is so that we can rinse it and make sure that all of the solid has been completely added to the volumetric flask. This is known as quantitative addition. I'm also rinsing out the funnel to make sure that I have added all of the solid that remains in the funnel to the volumetric flask. To speed up this addition, I can just pour directly from my distilled water bottle into the funnel. Notice that at this point, the volumetric flask is full about halfway. I cap it and shake to dissolve the solid. You want to make sure always to dissolve solid all the way with the volumetric flask about half full. If you've added water completely to the line, it becomes very difficult to shake it well enough so that the solid completely dissolves. Notice that this can take a while. Once the solid has been dissolved, we add enough distilled water to get very close to the etch mark on the flask. You want to make sure you don't add all the way to the etch mark because it's easy to go past it. This clip has been sped up to save a little bit of time, but you can see that I have not quite reached the etch mark on the flask. Now I'm going to use a plastic pipette with distilled water to get the meniscus to line up with the etch mark on the flask. Notice I'm doing this carefully because if I go over, I have to start over in the preparation of this solution. I'm going to cap it. Notice here that the meniscus is touching the etch mark on the flask. Now you can cap it, shake it, invert it several times to make sure the solution is uniform and ready to use for your titration. Next, I measured out 25 milliliters of distilled water and I'm adding that to my Erlenmeyer flask. I'm preparing the acid solution for the titration. I will also add the indicator, which is phenolphthalein. I add just a few drops of this, and this will change the solution color to a faint pink when the solution has reached the endpoint. I'm also adding a stir bar so that I don't have to keep stirring the solution while I titrate. Now I'm going to take my acid solution and I'm going to be measuring exactly 10 milliliters of it using this volumetric pipette. Volumetric pipettes are set to deliver 10.00 milliliters of the solution. To use a volumetric pipette, you squeeze the red bulb and then place it at the top of the volumetric pipette. You release the bulb, allowing solution to be drawn up into the volumetric pipette. At this point, you'll notice that it wasn't full. I just filled it about halfway so that the volumetric pipette is not contaminated with any other solutions or water that could dilute my solution. Now I'm going to fill my pipette. I added more of the acid to my beaker. I squeezed the bulb and I am drawing up solution into the pipette by releasing the bulb. I am going to draw up solution above the line marked on the pipette and I turn the pipette to release some of the solution. So I have my finger capping the top and I spin the pipette until it reaches the line. Once I have reached the line with the solution, I quickly cap the top of the pipette with my finger so that no solution drains out, and then I drain it into the volumetric flask. Notice that there's still some solution remaining in the tip of the pipette. That is the correct way to do that. You should not push it out because otherwise you'll have the wrong volume. Now that I have added the acid solution to the Erlenmeyer flask, I am ready to titrate. Now I need to prepare my burette for the titration. Think about it. To prepare our burette, should we first rinse it with water or our base solution? I'll give you a few seconds to think it over. If you said that we should clean the burette with water first, you're correct. We want to remove any contaminants that remained in the burette from the previous user. We are going to rinse the burette with a little bit of water, release some through the tip of the burette, and then rotate the burette so that the water coats the sides and rinses any impurities that were in the burette before. Do this a few times to ensure that your burette is ready. Now we will rinse with our sodium hydroxide solution. The reason we rinse with this last instead of first is because we want to make sure that we're not diluting our unknown base when we add it to the burette. So we add some of the base solution to the burette and we let some drip out of the tip into the waste container. We also rotate the burette to let the NaOH drip down the sides of the burette and make sure we remove any water. When I'm ready to fill the burette, I place it in the burette clamp and I use the funnel, making sure to hold the funnel in place so that I don't accidentally overfill the burette. Once I have filled the burette, I'll drain a little bit out of the bottom to make sure that there are no air bubbles in the burette tip. Now that our acid solution and our burette containing base are prepared, we are ready to begin the first trial of our titration. First, we record the volume on the burette. It currently reads 0.40 milliliters. Let's make a prediction. What do we think will be the volume when the end point of the titration is reached? Will the burette be empty? Will it be partially empty? Think about it for a second. To begin the titration, we're going to add the acid solution to the stir plate and turn on the stirring. Now we're going to slowly add base solution from the burette to the Erlenmeyer. At first, you can add it fairly quickly, about a milliliter at a time. When you notice the pink color start to persist for a few seconds, you can slow down your titration and start adding your titrant, the sodium hydroxide, dropwise. You can see that the color is not really persistent, so I keep adding large amounts of the sodium hydroxide. Now I will add it dropwise. Keep a close eye on my titration as it proceeds, making sure to note the duration of the pink color. The first titration often takes a long time because you don't know where the endpoint will occur. So we wait for the pink color to persist. When you notice the pink color of the solution persist for a few seconds when you keep adding titrant, what you can do is slow the addition of the titrant. You turn the handle to turn off the flow, and then you do what's called a quick addition by doing a quick twist of the burette handle. Notice that as I do this, the pink color is starting to persist for longer. When the pink color persists for about 10 to 15 seconds, your titration is complete. It does not need to remain pink in order for the titration to be at its endpoint. Now the solution is faint pink. That means we've reached the endpoint of the titration. Looks good. Now we can record the final volume on the burette. Here we can see that it's 12.60 milliliters. If we add another drop of titrant, we see that the solution is a bright pink. That's a no-go. That means we had the endpoint correct before we added that final drop. We pour our waste into the waste container. Oops, I lost my little stir bar. I'll have to grab some tweezers to pull it out of the waste container. I'm going to use that stir bar for my next trial of this titration. I've now cleaned my stir bar by wiping it and rinsing it with distilled water. Now I'm also going to rinse my glassware with distilled water. I rinsed the Erlenmeyer a few times with distilled water to make sure that it's ready for my second trial. I'm going to add the stir bar back in, and now I'm ready to prepare my solution for my second trial. I have 25 milliliters of distilled water that I will add to the Erlenmeyer flask. I'm going to again add a few drops of indicator. And I'm going to pipette 10 milliliters of my acid solution into the Erlenmeyer flask. Notice that when I use the pipette, I'm going to fill it with solution above the brown mark. I'm going to allow the solution to drain by slowly turning the pipette while my finger is clamped on top. This will prevent all of the solution from draining out and will allow me to add the appropriate amount as indicated by this orange arrow. I allow this to drain into my Erlenmeyer flask. After the acid has drained from the pipette into the Erlenmeyer flask, I will be ready to do the second titration. I'll place the Erlenmeyer on the stir plate and record the initial volume of the burette. For trial 2, I refilled the burette with sodium hydroxide. Now the initial volume reading on the burette is 0.80 milliliters. I will record this reading on my data sheet. Now let's make a prediction. What volume of sodium hydroxide should we expect to drain out of the burette for the second trial? Should it be more base, less base, or the same amount of base? Take a minute to think about it. Now that I know how much titrant I used in the first trial, I would expect my second trial to use about the same amount of base because I've added the same amount of acid to my Erlenmeyer flask. So now I can drain a lot of sodium hydroxide at a time, similar to the amount I used previously. When I get within about a milliliter of the endpoint of the titration, I will slow the addition. When the color persists for a few seconds, I'll slow it down even more and start to add my sodium hydroxide titrant dropwise by doing the quick turn technique on the handle of the burette. After a few turns, you'll see that the pink color really starts to persist. When you see the pink color persist for 10 to 15 seconds, the titration is complete. Whenever you're not sure, all you have to do is record the volume on the burette. Here the final burette volume is 13.00 milliliters. Then you can always add one more drop of titrant to your titration to make sure that you've reached the endpoint correctly. Here, when I add one more drop, you can see that the pink color is too bright and we've gone beyond the endpoint. After our 2 trials in Part B, we will start Part C, where we dilute our oxalic acid and do 2 more trials of the titration with the sodium hydroxide solution. Our first step will be to measure out 15 milliliters of our acid solution from Part A in a graduated cylinder. Make sure that when you look at the meniscus on the graduated cylinder, you look at eye level. When I've measured out the correct amount, as you can see here, the meniscus reaches the 15 milliliter mark on the graduated cylinder. I'm going to take this solution and add it to a 50 milliliter volumetric flask. I'm adding carefully so as not to lose any of the acid solution. I'm going to rinse the graduated cylinder with distilled water to make sure that I transfer all of the acid to the volumetric flask. Now I'm going to quickly fill the volumetric flask with water to just below the line. This clip has been sped up to save a little bit of time. Now I'll use my plastic pipette to fill to the line on the volumetric flask, making sure the meniscus touches the line. Now I'm going to cap and invert the solution to mix it up and make sure that it is uniform throughout for my titration. I will set this aside. Now I'll measure out 25 milliliters of distilled water, add it to the Erlenmeyer flask, add my clean stir bar, and a few drops of indicator, just like we did for the titrations in Part B. Now I'm going to use a graduated cylinder to add the diluted acid to the Erlenmeyer flask. Since I'm using a graduated cylinder, let's take a second to make a prediction. How do we think that using a graduated cylinder compared to a volumetric pipette will affect the number of significant figures for this step? We'll answer this question by recording the volume of the dilute acid in this graduated cylinder. The volume here is 12.5 milliliters, one fewer sig fig than we had with a volumetric pipette. Make sure to record this on your data sheet. Now we will show you trial 1 of Part C, where we use the diluted acid to determine the concentration of our solution. We will set it up just as we have before. We have our diluted acid solution in the Erlenmeyer, and we need to record the initial volume on the burette, which is 13.00 milliliters. Now we begin our titration. Before we begin the titration, let's make a prediction. Do we expect to use more base less base or the same amount of base now that the acid has been diluted. I perform the titration exactly the same as before, except I'm going to add the base a lot more slowly. I expect that since I have fewer moles of acid since the solution is diluted, that I should need fewer moles, aka less of a volume of base, to complete the titration. I will do the same dropwise addition as before, and when the solution is faintly pink for 10 to 15 seconds, I record the final volume on the burette. You can see here this reading is 17.20 milliliters. We're going to perform the second trial of Part C, again using the diluted acid solution. We measure out the diluted acid in a graduated cylinder. Here you can see we've added 11.5 milliliters. Record this volume. Now we're going to add the distilled water to the Erlenmeyer, along with the indicator, a stir bar, and the acid that we just measured out, 11.5 milliliters. Now we record the initial volume of the burette, 17.35 milliliters, and perform this titration the same way as before, expecting a slightly smaller volume of sodium hydroxide to have been used for this trial because we used a little bit less of the diluted acid for this trial. This has been sped up for ease of viewing. The final volume on the burette is 21.40 milliliters. After recording the final volume of the burette, I add one more drop just to make sure we had the endpoint correctly. This dark pink color indicates we're now well past the endpoint and we had it right initially. Now make sure to complete your datasheet and show all of the necessary calculations that your instructor is requesting. If you have any questions, please communicate with your instructor. Hope you learned a lot about titrations today.